Dear guests, dear organizers, I'm speaking now from Haifa, a beautiful northern city of Israel located on Mount Carmel that goes down to Haifa Bay on the Mediterranean Sea. I'm very excited today to give you a presentation of our work, helping people to hear each other better. But first, a few words about us, about Alango Technologies, the company that I founded 21 years ago. Let's go to our office now. Welcome to Alango. We make digital sound better. Our digital signal processing technologies reduce noise, remove acoustic echo, increase speech intelligibility, and improve music perception. Our software has been integrated into more than 70 million products, including cars, speakerphones, conferencing systems, headphones, and earbuds. But today, I'm going to talk about the area where we're still a startup. That area is hearing enhancement. Why are we investing into it? To answer this question, I would like you to watch a clip from a video that we made 8 years ago when we asked ourselves, what is the most needed wearable electronic device in the world? Fitness bracelet, smartwatch, smart glasses, smart clothes? No. It's a hearing aid. We made this video when we started our work with hopes to change hearing health in 5 years. It didn't happen, but we are still optimistic and want to change hearing health in 5 years. So, why do we think that hearing aids are the most needed wearable electronic devices?
According to the World Health Organization, 430 million people today suffer from disabling hearing loss. Not just some hearing loss, but hearing loss that makes them handicapped. By 2050, this number will increase to 700 million. The good news is that the majority, 95% of these people can benefit from hearing amplification. But the bad news is that only 70% use it. Today, there are 340 million people who desperately need help with their hearing. And unaided hearing loss has multiple health and social consequences. For example, did you know that untreated hearing loss in the middle age is the most significant risk factor for dementia, responsible for 8% of all dementia cases in elderly? More than the next 4 factors combined, which are brain injury, high blood pressure, alcohol, and obesity. Surprising, isn't it? Untreated hearing loss in children delays language learning and social skills. In adults, it doubles unemployment rates. It increases family tensions, and in elderly, it is associated with social isolation and depression. The total cost of untreated hearing loss is now estimated at $750 billion annually.
400 million people can benefit from hearing amplification. Unfortunately, the hearing aid industry failed to find a solution to most of them. What else can be done?
We believe that hearing enhancement shall be a standard and free of extra cost feature in the majority of consumer electronic headsets and earbuds, similar to transparency mode in active noise cancellation. We don't even need to call it hearing enhancement. Let's call it amplified transparency, or as Apple named it, conversation boost. Is this functionality difficult to integrate? To get an idea, let us compare over-the-counter hearing aids on the left and true wireless earbuds on the right. They both integrate microphones, speakers, rechargeable batteries, and they both offer Bluetooth connectivity. To implement the audio functions, they both have digital signal processors, which are small computers. The only major difference in the software that runs on disintegrated DSP computers. And that is what our company, Alango Technology, offers. When integrated into consumer electronics products, our software delivers personalized and amplified sound that enhances hearing in face-to-face conversations, assistive listening such as TV, personalized audio playback, and personalized voice communication.
But how do we know that our hearing enhancement technology really works? That it helps people as well as advanced hearing aids do? You cannot create a product if you don't have feedback from multiple users. But you cannot have multiple users if you don't have a product.
To solve this chicken and egg problem, we developed our own brand of consumer electronics concept products, which we call Be Here. Today we have two main products. Be Here Access is a neck-type hearing amplifier. It is designed for active people in their 50s or 60s who need situational hearing assistance. It provides up to 45 decibels of personalized hearing amplification, helping people with a moderately severe hearing loss. Be Here Smarto is designed for older people with severe hearing loss. Smarto is easy to use and adjust with its large, colored volume buttons and tone control buttons. The Be Here products support full Bluetooth stereo headset functionality with personalized sound according to the individual hearing loss. Both products have received several professional and consumer industry awards. Industry awards are good, but positive feedback from Be Here users is even more important to us. They give us the motivation to do even more. Let us hear one of them.
I can hear again. I can hear the music. I can hear children's voices. Smarto has changed my life.
Integration of hearing enhancement into consumer electronics products such as Be Here helps to solve three main problems associated with the low penetration of hearing aids. First, the social stigma of wearing hearing aids. Hearing loss is still associated with being old and disabled, something that nobody wants to admit. Second, the high cost of hearing aids. Hearing aids are not everywhere covered by insurance, and only few can afford them without it. Third, the lack of audiology services in remote rural areas. Consumer electronic products, such as mobile phones and headsets, are everywhere today. But there is a fourth problem associated with even the most advanced hearing aids. The problem is the performance in difficult acoustic conditions.
The statistics says that 20% of people who bought hearing aids returned them. 17% are not satisfied. 7% do not use their hearing aids, keeping them in a drawer. They feel that hearing aids do not help them when they mostly need them in noisy or reverberant environments. Noise reduction in acoustic signals is not a new topic. Classical noise reduction, based on spectral subtraction, was first introduced in 1979. Starting from 2015, machine learning algorithms based on neural networks became a topic of extensive research. Let us compare the two approaches for the purpose of hearing enhancement. Classical noise reduction is still used in most, if not all, hearing aids available today. It has several advantages such as low computational resource requirements, low processing delay, easy integration into software frameworks of existing consumer electronics Bluetooth chipsets. However, it suffers from slow convergence time to follow fast noise level variations. It only reduces stationary noises, and it has limited performance at low signal-to-noise ratios. Neural networks have a lot of potential. They converge very quickly. They can be trained to suppress non-stationary noises. They show better performance at low SNRs. However, they are more computationally intensive. They introduce processing delays that are unacceptable for hearing aids. They are more difficult to integrate into DSP frameworks, although this may change in the future. A typical signal processing pass in a digital hearing aid consists of microphone beamforming, acoustic feedback cancellation, wide dynamic range compression, and noise reduction. All this shall work with combined microphone to speaker latency of less than 10 milliseconds and power of less than 5 milliwatts. There is no way a neural network can be integrated inside this path. Our solution introduces a parallel neural network path that is less time critical. The purpose of the network is to calculate the optimal processing parameters for the low latency path with maximum latency for 30 milliseconds. This decision-making delay is unnoticeable due to the backward masking phenomenon of our auditory system. This path may include several specialized networks, each one responsible for a specific task. The networks must be compact enough to allow integration into chipsets used in headsets and earbuds. Alango has developed two such ultra-small networks, noise reduction network and the reverberation network. The convolutional noise reduction network has only 8 layers and 1700 parameters. It requires only 25 million simple arithmetic operations per second. It works pretty well, however, due to its ultra-small size, it can handle only a small variety of noises and speech levels. To extend it, we've introduced a pre-processing block that performs automatic gain control, adaptive noise equalizer, and speech emphasizer. Let's experience how it works.
Imagine yourself to be a hearing aid user having a conversation with me in this beautiful place with the sea and the noise coming from the sea. Imagine yourself to be a hearing aid user having a conversation with me in this beautiful place with the sea and the noise coming from the sea. This noise may be good for you if you are a normal hearing person, but it may be catastrophic if you use hearing aids. This noise may be good for you if you are a normal hearing person, but it may be catastrophic if you use hearing aids.
Our convolutional dereverberation network is just a little bigger. It has 2300 parameters and requires 33 million operations per second. We tested it in a wide variety of reverberant places. Here is one of them.
Now imagine yourself to be a hearing aid user listening to me in an underground parking garage with strong reverberation. Now imagine yourself to be a hearing aid user listening to me in an underground parking garage with strong reverberation. Reverberation may be annoying for people with normal hearing, but it is catastrophic for speech intelligibility for people with hearing loss. Reverberation may be annoying for people with normal hearing, but it is catastrophic for speech intelligibility for people with hearing loss. We are still in the early stages of applying machine learning approaches for digital signal processing for hearing enhancement. Combined with recent advances in consumer electronic chipsets and acoustic components, we can eventually expect a revolution in hearing health. I would like to thank organizers for inviting me to give this talk. Thank you all for your attention.